engagement and commitment to professional excellence. So Mr. Taj is also an author, a respected author. He has a book written called Medical Laboratory Manual, which is a comprehensive guide that has been received in academic and professional circles. And at this time, Taj, if you can hear me, I want you to just say hi and proceed.
I can hear you, but I don't know whether you can hear me.
Yes, we can hear you. Just proceed.
Okay, just wait. Don't go. I'm in a little bit of a jam here. Okay, can you see the slides?
Yes, we can see the slides.
Okay, fine.
Go to presentation mode and proceed.
Okay, go to presentation mode and proceed. Okay, here we are. Okay, thank you everybody. Welcome. This is a interesting topic. It took me a very long time to understand it. And I owe the information in this presentation to Daisy and Lewis from the book Practical Haematology, of which most of you are familiar. So this method is partially available on Practical Haematology by Daisy and Lewis. You can verify it. I think it's page 499. So let's go. We'll try and prepare a secondary control in the lab, which will be viable for at least 20 days. Okay, the major pitfall of commercial controls is they have a short life after opening. Even before they are shipped, I think they only have about 60 or 90 days. So this is the problem that we face, all of us face in the laboratory, especially when we are in faraway places. There are times you don't get the controls in time, or if they come, they have a very short life, and you use them up and you don't have anything. So this is a backup. This is your plan B. So the purpose of this presentation is to give you a plan B. So there are times it's not delivered on time, at times it's been held up at the airport, and also it is an expensive item to buy. Okay, so this is a blood bag where you're going to collect the CPD. So this is the materials you will need. You need you need a hematology analyzer which is ready to use, which has already been calibrated and QC done using commercial control. So you need to have a fully operational commercial analyzer which has been checked and it is ready to go. Then you need CPD from the blood donor bag, which we just took a photograph of. You need just 1 ml of CPD. And then you need gentamicin. It comes in a sealed ampule. It's usually 2 mLs. We are going to use a very small amount in it. This is usually available from your pharmacy. They will always have an ampule of gentamicin. This is to slow down the growth of bacteria and fungi. Then this is where you have to, this is this is number 4 is the secret. You prepare, you dilute 1 ml of neat formalin with 36 mLs of sterile injection water. So your final volume is 1% formalin. So I'm repeating, you want to prepare 1% formalin. So you're going to take 1 ml of formalin neat, which is 37%, and add 36 ml of injection water, which is sterile. That again, you go to your pharmacy and you'll get. Now, when you go to the formalin container, you will see a white precipitate at the bottom of the formalin container. Don't shake it, just take formalin from the top. So I'm repeating, basically you need a CBC analyzer ready to go. You need 1 ml of blood donor CPD. You need 2 mLs of gentamicin from the pharmacy, and you need 1% formalin. Also, you need a willing lab staff to give 4 mLs of blood in a vacutainer EDTA. You can recheck HIV, hepatitis B, C, and TB. The secret is the formalin. Okay. So you have collected 4 mLs of blood in EDTA in a vacutainer tube. Mix it well, use a sterile pipette, and discard 1 ml. Now you remain with 3 mLs of EDTA. Okay. To the 3 ml EDTA blood, add 300 microliters, 0.3 of CPD. So that is now you're giving it dextrose, phosphate, citrate, phosphate, dextrose. You're giving the nutrition to your red cells. Just like blood donor blood is given enough nutrition in the CPD bag. Then you are going to add 10 microliters of gentamicin. Since you have opened the vial, you need to safeguard it. Then you add 150 microliters of 1% formalin. That's 0.150 or 150 microliters. Mix. The amount of formalin is very small. It's half the amount of the citrate phosphate dextrose. Mix well, 10 minutes, and then you run it 3 times on the analyzer and you take the average. Label and store at 4 degrees. Okay, sorry. Count is consistent for 20 days, even a little more, but let's assume 20 days. Good enough. 4 parameters are very stable: HB, RBC, WBC, and platelets. This method is not totally suitable for differential, but it is close. It will even give you the differential. The difficult part is the WBCs. They go through apoptosis and they start dropping. But that's after 14 days. So I'm going to give you an example we did in the lab. There you are. 6th April, we got RBC 4, WBC 5.3, HP 13.6, platelets 184,000. On 1st of May, we had closed. RBCs were closed. They were well looked after, nutrition and living. WBC dropped a little bit. HB is very stable and platelets is stable. The differential also is quite stable. So the lifespan of the control is about 20 days. So the ratio of blood to CPD is 1:9, which we did 3 mLs plus 300 microliters. label and store at 4 degrees for 20 days. It is very stable. In fact, today I ran some differentials and it came up well. But now that is your experience. You have to prepare it and check how far this control can help you. But for HB, WBC, RBC, and platelets, it's very good. This method has been researched and a lot has been written about it. I'm not the only one. There are many people who have tried to use formalin to stabilize the different parameters. But even without formalin, your HB, your RBC, and your platelets are very stable. Very stable. It's only WBC which can give you a problem. So it's still useful, but you have to try it out. I want to talk to Fred now. I hope he can hear me. Fred? Fred?
Very good. I can hear you. I can hear you. Yes.
Okay. Can I just run it one more time?
Yeah, now you can run it, but a bit slow, a bit slower.
Okay. All right. Okay. Okay. What I'm trying to do here is to prepare an easy and low-cost hematology control in-house. Okay. So now, what is the purpose of our project? This is a plan B. When the commercial reagent is not available or has expired or has not come from the supplier, what do I do? So before that happens, you prepare your plan B and it is always available. So when you run short of commercial one, you have a backup rather than saying, I don't have anything, let me go and borrow from the nearest lab. So this is your plan B internal. Okay, this is, you need a blood bag. So what do you need? The materials you need is a blood bag, blood donor bag, from which you are going to extract 1 ml of CPD. You need a fully ready to use QC passed CBC analyzer, ready to use. You need 2 ml of injectable gentamicin from the pharmacy, which will help you now to cut down on bacteria because you are going to open the vial. So to avoid bacteria multiplying, you're going to add a little gentamicin. Now, you're going to take 1 ml of formalin, which is normally 37%, and add 36 ml of sterile injection water. This will give you 1% formalin. So be careful with formalin when you need a ventilated area, and look at the container if it has got precipitation at the bottom, which is usually white. Don't mix the formalin. Never mix it. You don't want the precipitate. You just want formalin, the top part. So 1 ml of formalin and 36 ml of injection water. You can reduce the volume and it will still work because the amount you need is very little. Then you need a willing laboratory staff to give you 4 ml of blood in a Vacutainer EDTA tube. You have to recheck his status, HIV, Hep B, C, and syphilis. Okay. So the cocktail is collect 4 ml of venous blood, put it on the roller, and take a sterile pipette and take out 1 ml of the ADTA blood and discard it. So you remain with 3 mLs. This gives you enough space in the tube. Okay. So to 3 ml CDTA blood from your colleague, you add 300 microliters of CPD. So the volume ratio is 1 part of blood, 10 parts of blood and 1 part of CPD. The CPD will preserve your red cells and platelets. To that, you just add 10 microliters of gentamicin, just 10 microliters to give it, to reduce contamination. Then this is the good part. Now you take 150 microliters of the 1% formalin which you made in water, sterile water, just 150 microliters, and you mix. Mix for 10 minutes, 15 minutes, perform your CBC 3 times, and take an average. And you are ready. For the next 20 days, you are fine. So this preparation is done while you still have a commercial blood. So that when the commercial blood runs out, this one is just plan B, plan B. Count is consistent, guaranteed, 20 days for sure. HB is stable, RBC is very stable, HB is very stable, platelets are very stable, WBC, there are issues. It doesn't preserve very well. But it's still 14 days, it's still good to go. But for up to 20 days, it will be within 2 SD. Okay, this is an example. On 6th of April, we got RBC 4, WBC 5.3, HB 13.6, platelets 184. 1st of May, RBC stable, WBC a little down, HB very stable, platelets very stable. If you decide not to put formalin, it still works, but only your RBC, HB, and platelets will be very stable. Your WBC will drop. Okay. Basically, what we are trying to do is just preserve the blood, just like you preserve blood on a blood. The ratio of CPD and blood is the same, 1+9. Label and store. A lot of work has been done on this particular stabilizing with formalin. And they're good papers, you can look them up. Okay, I'm done. I don't know whether we have Fred. Fred, are you there?
Yes, I'm following closely.
Okay.
Yes, good.
I just want to know if there are questions.
Yeah, thank you, Senior, for the very able presentation. Now, there are quite a number of, I can say there are questions and comments. And maybe if you have any other concern, you can just come to the chat box so that we can discuss together. So Michael Bernard is saying on point presentation and good mastery of the content, thumbs up. And then Juliet Chelagat is saying nice presentation. Have a concern on how to go about the ranges as for the commercially prepared. Okay.
Fred,
Taj,
I
did you hear me?
don't, I can hear you, but I didn't understand the question.
Yeah, okay, I'll just read the way it is. She's saying, I have a concern on how to go about the ranges as for the commercially prepared.
Commercially prepared, okay,
saying,
go on.
She's saying the commercially prepared usually come with ranges. What about these locally prepared?
Okay, now I got it. Okay, what you are going to do is you are going to make your own range against the commercial one. So when your analyzer is ready and has been calibrated on the commercial analyzer and it is ready, the QC is good. Now you run your in-house and determine your values. So you cannot prepare this cocktail when you don't have a commercial control. You have to have a commercial control. And you have to have an analyzer ready to now give you the values for your secondary plan B control. Okay, I think that's the best I can do.
Yeah, sure. That was quite in order.
Okay.
I think there's a concern, and these I can see from quite a number.
Yes.
While running controls, is it a must that we run the 3 controls? And again, someone is asking, will this be a normal control? Elvis Lishamba.
Yes, this is your normal control, but then this is where your ingenuity will take place because you'll prepare normal control now, find out how good it is, what are the pitfalls, how it is working. Then you manipulate and prepare low and high. By preparing high, you are going to remove some of the plasma. By preparing by preparing the low, you are going to add more plasma because you will collect 2 vials of 4 ml. By doing the high volume control, abnormal control high, you're going to remove some of the plasma. So that manipulation will come later. First, prepare the normal control. Be satisfied with it and know that now you have the hang of it. You have to get the hang of it. You have to experience it. So prepare the normal, then you will prepare low and abnormal. It's not difficult. It's a matter of just manipulating the blood. But everything hangs on to the fact that you have a commercial control now running and you have an instrument already calibrated. It cannot be done without.
Thank you, Taj. I think there are still more concerns, and this is from Davis. Thank you, Davis. Number 1, considering that IQC materials should be commutable, to what extent do formalin stabilized CBC controls mimic real patient samples across different analyzer methodologies?
I would refer him to those 3 people I showed. The people who have already worked on this formalin. So I've given you the references. I think you look up those papers. They will help you. I can't help you there because they have done a lot of research on it.
Okay, thank you. So Margaret Nuna is asking, are you not going to compare the initial test of the 4 males you acquired from your friend? Just thinking.
No, I want to make more space to be able to mix well, because when you collect 4 ml of blood in a 4 ml EDTA contained tube, there is hardly any space there. We tried it and we failed. So by removing 1 ml, we are getting enough space to, to, to mix the blood well.
Okay. Then David, another question. This is to what extent do routine CBC IQC materials cover rare or critical values such as extreme anemia, severe thrombocytopenia, or marked leukocytosis?
I'm not getting it. Can you say that again?
To what extent do these routine CBC IQC materials cover rare or critical values? And she goes ahead to give some examples like extreme anemia, severe thrombocytopenia, or marked leukocytosis.
You see, Fred, what happens is just the commercial reagent, when it comes, you use it to calibrate your machine. So when you use it for calibration and QC of your machine, and your machine passes the QC, so the machine is ready to take everything which is low and high, depending on the linearity. So similarly, your normal control, which we have prepared now, is just helping you to make sure your analyzer is functioning. But your machine is ready. It has certain amount of linearity, and it will flag if the results are too low or too high. Just 1 second, Fred. Just 1 second. I want to pick some coffee. Nadimu moja.
Okay, I'll read this from Dr. Evelyn Kutolo. Thank you, Dr. Evelyn. She's saying, my take is you select a sample based on the findings on the machine, that is high count, normal findings, low findings, then use them as controls.
Exactly. Very brilliant. I was coming to it. That's exactly what you do. But there must be, you must collect the sample in 4 ml 4 ml Vacutana EDTA, and then you remove some of the blood to get enough room to mix well. Because if you collect 4 ml, it's right at the top of the bung. No, I agree with her. You can use a patient, but it has to be HIV plus Hep B, C, and TP negative.
Very good. I can bring another one. No, this is from okay. From Nelson Odede. She is asking, what's the use of gentamicin? And he's also asking, why do we fix the sample?
Yeah, it's a good question. Why are we using gentamicin? You see, once you open the EDTA cap, the air has already gone in. So you want to curb the growth of bacteria or fungus. Now, the other issue of fixing. A lot of products have been used. Several other products have been used for fixing the WBC, which is the problem. So in commercial CBC blood you get, they use glutaraldehyde, and they are smarter also. When they are preparing that CBC blood for WBC, they use turkey RBCs, which are more viable, but a turkey being a non-vertebrate, all the RBCs have got a nucleus. Only vertebrates, their blood cells, red blood cells, have no nucleus. But in the invertebrates, the blood of a chicken or a turkey, all the red cells have a nucleus. That's standard. So they are smart. They are using RBCs from a chicken, which is more viable, and letting it be counted by the analyzer as a WBC. The best thing you can do if you really want to experiment this is take out a small drop of the commercial CBC blood and make a blood film and look at it. You will see the cells are all flat. How do you call it? Fred, how do you call a flat cell? Which does not have a dimple. And then you will see the WBC are nucleated. Just like your analyzer, when it has nucleated RBCs in humans, it counts it as a WBC. So your comment is good, but you have to try and make a blood film of the commercial control to experience what is really happening here. Fred, are you there?
Yeah, I'm there. Let me just add this comment from Davis Wanjala. Formalin is for cellular stabilization to prolong viability duration. Thank you, Davis. That's very true.
Thank you.
That's very true. Now, there's another question from Kipto Collins and another one from Jacqueline. Which tube should we use when storing? Is it plain or EDTA?
EDTA, the same tube. You don't change it now. You use the same tube. Unless if you want to, if you are some of people, what they do is we have 3 mLs. So you leave 1 ml there and you allocate 2 mLs in another EDTA tube, but you wipe the EDTA out. You wipe it off. So you shake the tube and remove the EDTA. The best thing is wipe it. So you have 3 tubes with 1 ml of blood in each. That way, you have 3 controls. So if one goes bad, the other 2 are still running. But the viability is the same, it doesn't change.
Thank you, Senior. Thank you. Maybe we'll go to our final questions. Kipto Collins, what if HB, RBC, and WBC has not passed? After repeating 3 times for normal control, do we run the patient sample? Thank you, Collins, for the question.
I think what is to be understood here clearly is you have a hematology analyzer already calibrated, checked, and QC checked, and it's functional with a commercial CBC blood from a commercial supplier. Then, and only then, are you able to prepare your own Plan B blood. You cannot make Plan B without the original. So I've not probably replied you well, but you need the CBC original before you calibrate your secondary reagent. You cannot prepare your secondary reagent without calibrating the machine and keeping it ready now to move. So your values are to be recorded now for the secondary.
Okay, there's another question from Regina Nderito. Hello, is it possible to prepare the solution daily for the sake of WBCs? And then Gilbert is asking, why the short lifespan, yet RBCs has 120 days?
Okay, that's a good one. That's a good one. Now, let me see if I can get back to the slide. WBCs are troublesome. They tend to disintegrate. It's called apoptosis. Apoptosis. Let me see if I can get the slide in. If I hope I can get the slide in. Basically, you have a problem. And the problem is it's called apoptosis. Please look it up. That is where the problem is. Even in a blood donor bag, platelets and RBCs are well nutritioned and well preserved. But WBCs disintegrate slowly, but they do. They are not preserved. So that is my answer to you. But these people who have done research, they have found that formalin tends to hold it for at least 14 days without a problem. But it can be extended up to 20 days. But 14 days for sure, your platelets, your WBC will be within the 2SD. Sawa?
Very good, very good. Okay, let me pick something here. And this is Juliet Chelangati saying, I have another observation on the person to give the blood. Should not be anyone willing, because someone could be willing but with deranged values. Another issue still on the ranges is, if this is a plan B on QC stockout, then something should be done on the ranges.
Yes, I agree with him. Now, the problem is that comes now under long research, trial and error issues. So to shortcut the whole procedure, this is what I've got for you. And this is what is being used in a lot of laboratories in places like India. And papers have been published. I think I've only given you 4 papers which have been published. Most of them seem to be from India and Spain. But if you want more information on this, I suggest you go to the 12th edition of Practical Hematology by Desi. He's given a very good explanation, and he has used glutaraldehyde to preserve the WBC. And it works very well, but it's a long procedure, and looking for certain other reagents apart from formalin to preserve the WBC is something you are not going to find. And if you find it, it's mainly too expensive. Formalin is just around the corner in your histology, and you don't need much of it. You just need 1 ml. That will last you another 3-4 years because you only are using 150 micron. But this method is cheap, doesn't have too much fuss, it doesn't have too many reagents involved. It's simple, and it's something you need to get a hang on to it, and then prepare normal, prepare low, prepare high. And it works pretty well. And it has been working in many laboratories, and several papers have been written about it. Fred, do you want me to go through? Do you want me to go through the paper again for those who joined late?
Maybe you can brush over one last time, then we can end. I think that we have handled all the questions and concerns.
Okay. So let me just see here. We are okay. But you can hear me clearly, eh? Fred?
It's very clear. It's very clear. It's very clear.
Okay. There you are. Now we have put it in Zoom. This is an easy, low-cost preparation of CBC hematology control in-house. This is the purpose of this webinar, is to give you a way to prepare a plan B, simply because commercial CBC controls have a short life. Sometimes they are not available on time. Sometimes they are stuck at the airport, and of course they are very expensive, but you need them. So this is a blood bag where we are going to collect the citrate, phosphate, dextrose to preserve the red cells. So what do you need? Materials you need is you need a ready CBC analyzer, which has been calibrated by a commercial control, which has passed the QC and is ready to use on patients. So you will use this as a patient and come to an average of the parameters you get, because you're going to run it 3 times. So you need an analyzer ready. You need 1 ml of CPD from the blood donor bag we just got. A blood donor bag is normally 150 shillings. A gentamicin, you need 1 vial, which is 20 shillings. And then you need 1 ml of formalin, 37%. And you dilute it with sterile injection water, 36 ml, to achieve 1% formalin. Then you need a willing staff to collect 4 ml of blood in an EDTA vacutainer. Then you recheck HIV, Hep B, C, and TB. Mix the blood, collect 4 ml of venous blood, mix the blood, and discard 1 ml. So you remain with 3 ml. Now to the 3 ml of EDTA blood, you add 300 microliters, 0.3 of CPD solution. Very little amount. The ratio is 1 in 10 here now. 1 part of CPD and 10 parts of blood. Then you add just a little gentamicin. Since you have opened the vial, that will stop the bacterial and fungal growth. It will reduce it. And then you have to add 150 microliters of 1% formalin. Mix it for 10 minutes, 15 minutes. Run it just like a patient for 3 times and get your average. If you don't want to use formalin, it's okay, but your white cell will drop. The other 3 parameters will be stable for 20 days. Okay, count is consistent for 20 to 28 days. HB, RBC, and platelets are very stable. The WBC tends to drop because it disintegrates. It's called apoptosis. And that after 14 days, it does drop. Not too much, but it does drop. You will notice it. It's better if you try the system on your own to experience it. This is what we got, 6th April, 4 RBCs, WBC 5.3, HP 13.6, platelets 184. 1st of May, that's almost 3 weeks later. These are the values. You can see RBC is very stable, HP extremely stable, WBC tends to drop. Platelets stable, very stable. And the differential also is stable to some extent. But it's something you need to experience and develop. And then you can prepare normal control, you can prepare low control, you can prepare high control. But start with the normal, don't rush. Okay, the lifespan is about 20 days. Store at 4 degrees. Some people tend to allocate it and put 1 ml in another EDTA tube, which they have removed the EDTA. So all those manipulations can be done. Then there is, of course, the references. You can look it up when the slides come. And one more reference here is you can go to Practical Hematology by Dacey and Lewis. You can read, he's mentioned it. He even shows you how to use it. But then you need glutaldehyde. And here in our method, we are using simple, basic, cheap formalin. Okay, Fred, I am ready to put the next slide with your permission, but we can answer some questions.
Yeah, I think we are good. We are good. You can go ahead.
Okay. So the last time I did a webinar, we had talked about doing white cell count and a platelet count on a blood film. So my housekeeping, I want to just do a little housekeeping because somebody asked a very important question and I needed to go and look it up. So he asked a question that okay, let me just put this away. That how accurate is this method when the platelet counts are very high, well, the white cell count and the platelet counts are very high. So I'm trying to see, here we are. Okay, so this is the answer of your accuracy. When you're doing platelet count, our WBC counts, when the white cell count is below 2000, your accuracy is very high. But once you go above 11,000 up to 30,000, you will also be very high by using a blood film. And then once you pass the 50,000 mark, you have very poor precision. So what I'm trying to do is the method of counting WBC, estimation of WBC on a blood film, you can see that is as high as 30,000. It's very, your results are good. So we go to one more slide, and here is the platelets. Your accuracy, when it is 20,000, is best. Then once the platelets go over 400,000, then your accuracy is poor. I just want to show you one more slide, and then I have published a book, and if you need to buy it, you can M-Pesa me 2,500, and I will send it to you transport paid. Fred, I want to thank you. I want to thank the organization for giving me this opportunity. And I hope that the methods I've described today will be helpful. If there are any questions, I will take them. Fred?
Yeah, thank you, Taj. Able of you. And I think we had answered most of the slides, if not most of the questions, if not all. And maybe what is here are just accolades, and Frida Mugo saying, thank you, Senior. Maureen Kuria, great presentation. And many of you, Patricia Sefirino, this is very educative. Anne Wajoga, very informative presentation. Doreen Geshunge, great presentation. And many of you, Kiprono, Raymond, thank you so much for the presentation. Lydia Ngatia, informative. I think, thank you, colleagues. As always, we learn from each other. It was nice also engaging you in the chat box, a lot of comments, and this shows that we are committed to this profession. And maybe at this point, Senior Taj, I want to bring this back to you for your closing remarks.
I have been in this profession for almost 4 decades, and I still remember that what we need to do for our youngsters today who are now beginning in this profession is to make them experts on the bench, and for them to realize that even when the analyzer is not, hematology analyzer is not working, you can still do a white cell count, a platelet count from a blood film. Today, we prepared a CBC in-house blood, which helps you to keep your machine going, to have at least a good idea that, look, it has not failed and you're giving accurate results. Today's youngsters are the future of this profession, and I hope they will experiment and try and make this kind of control, or they will do estimation of WBC count and platelet counts on a blood film and arrive to a conclusion whether it is useful. I know it is useful, and I wish them well, but you have to read, you have to buy books. You can't keep on saying, I have a soft copy, I have a soft copy. No, you have to buy Monica's books. Those you have to buy. The 2 editions, the latest editions, the second edition is available from Textbook Center. Try and buy it. But you can't just remain without a book. When I interviewed 10 people for a job at Lions Hospital, all 10 told me they had soft copies of Monica. I asked them, do you have any other book, or have you got any books at all? The answer was nil. I don't have a single book. Now, this is where I don't agree. You must buy books. It is important to have your own small little library, starting with Monica. And thank you again, Fred, for the opportunity. Fred.
Thank you so much, Taj, for the very, very wonderful words to all of us here. And I'm sure I have learned myself, and from the comments here, everyone here has learned something, and I still
I've lost you.
encourage us, and that learning is see you then. Thank you and enjoy.